Okay, but because this group of students is too big, maybe I have 500 students, 500 samples. Okay, then I will split it into Monday. I'm gonna test on 100, and then Tuesday another 100 student, then Wednesday another 100 students. So each group of students are going to come to the school and involved in the test accordingly. So my IV is the coffee athlete. Coffee consumption. Coffee consumption, and the sport performance will be my DV. And I want to test whether this sport performance will be affected by coffee consumption. So this is my IV, this is my DV. Then the so-called confounding factors. Confounding factors means factors that are other than this IV which might affect your sport performance. What are the possible other factors that might affect your sport performance? According to this case study, different group of people that come on different day might affect their performance. So the days that you take coffee and you run, the day that you come will also affect your sport performance. But because this is not our IV, right? Which day that you come, it's not one of our IV. We did not say that coffee plus different day is our IV. We didn't do that. Okay, we just perform it because of the sample size, so we perform it. And therefore, this one, we did not consider this part as our IV, then this one could be the confounding factors that might affect your sport performance as well. Okay, that's called confounding factor. Factors other than your IV that might affect, which is not included in your hypothesis. Is that clear? Confounding factor. Is that clear? Confounding factors are factors that might affect your DV, but you did not include it in the IV. So we must try our best to avoid these confounding factors because we are not going to include it in our experiment. So try to reduce this. How can we actually try to reduce it? You can actually try to maybe since Monday is a blue day, Friday is another blue day. So maybe you try to avoid this and then you try to fit it into other days. Do something like this. Okay, instead of involving Monday and Friday. Okay, and then maybe you adjust it 60, 60, and then 70, maybe 80. Something like that. All right. So let's move on. That's how you can reduce the confounding factors impact on your experiment. External validity or generalizability, we have covered this in your assignment. To what extent would your result found in the lab setting to be transferable or generalizable to the actual organization of the setting? Meaning to say that I have done this in my lab or I've done this in TAR-UMT. Can I generalize this result or can I apply this result to other university? That's called generalizability of your result or external validity. To make a generalization from sample to any population means from TAR-UMT sample, you want to apply this result to other university. Sample must be an adequate and acceptable sample of that population. Adequate in the sense that, let's say, if you have, if let's say the population, right, of Malaysia university student is, let's say it is 500,000. Your population is 500,000, but your sample size is only 100 people. Can 100 people represent 500,000 population? Cannot. Your sample is only 100 people. Can that 100 people represent the 500,000 people or student? Cannot. So it is not adequate, not acceptable sample size. Right? And therefore you will need to know your population before you can decide on the sample size. External validity refers to the degree to which we are able to generalize your result of your study to other subjects under other conditions, under different environment, at other time, other place. Like for example, you have an experiment 20 years ago, right? You have an experiment 20 years ago. Does it actually applicable after 20 years, which is today? Let me show you something. Okay, this is one of the latest paper that that is accepted in the online journal of communication, OJCMT. Some of you try OJCMT, right? And this is mainly done by myself. And then all these are my colleagues. They are helping out with the data. But mainly 80 to 90% of the paper is actually done by me. Now, this research is done to find out whether usage of, this might be a good news to all of you lah. Okay, whether the usage of social media, smartphone, online game, online shopping, these four things, whether excessive usage of this will affect, number one, physical health, mental health, and also academic performance. A lot of people say if you play a lot of online game, then it will affect academic performance, right? If you are addicted to social media, it will affect academic performance, right? And then what we did here, we have 320 scholars involved in this experiment, and we found out that the result shows what? Social media addiction, smartphone addiction, online game addiction, and online shopping addiction do not significantly affect your academic performance. But it will impact your physical and mental health. So you feel so happy, wow, you can use this. It will not affect my academic performance. It will not affect my academic performance. But this is a straight one-to-one relationship. What if I put in something like this? This as a mediator means if you are addicted, which will affect this, and this one affect your academic performance. So this one will serve as a mediator. Then the result might be different. Anyway, we just stop here. We just stop at one-to-one relationship by using Pearson correlation. All right. So that's one of the results that we found out, which is very surprised lah. Because last time, 20 years back, if you are addicted to smartphone, definitely your result will drop. If you are addicted to online game, definitely your result will drop. But after 20 years now, it doesn't mean that the higher usage of smartphone means you have poor academic performance, because a lot of students are using social media and also smartphone in working out their academic, accomplishing their assignment. Different age, right? And therefore, you cannot generalize it in other places, in different places, different time, under different condition and environment. In a research project, rates of defect detection of particular testing scheme were calculated and contrasted. This is one example. It turned out that scheme A was better than scheme B in discovering defects of functionality and usability. So they want to carry out a research. They use 30 programs written by master student using C programming language and then the program was between 20 and 1,000 lines long, how well would the result that method A is better than method B? Method A than B means we want to use this method to discover defects of your program. Defects of your program. And what are the program? 30 programs written in C programming. The program will have 20 to 1,000 lines long. Okay, now in this situation, can we say that because this is in C programming language, and after they have done this, after they have found out the result is that scheme A is better than scheme B to discover whether your program is better than scheme A is better to find out the defects in the program as compared to scheme B. Okay, but then can you say that scheme A, can you generalize it and say that scheme A is better than scheme B in discovering defects of function and usability in all the programs? You cannot say that. In all the programs, regardless of the programming language, you cannot say that. Because this research is focusing in C programming language only. How about C#, C++? How about PHP, Python, ASP? Oh, you have so many different programming language which you didn't test it in this experiment, in this research. And therefore you cannot generalize it. You cannot generalize this result and apply it to other city, other professional, other object paradigm, other programming language. You can only use it for C programming language. Okay, let's move on. So that is the external validity or generalizability. The next one is statistical validity, extent to which data are shown to be the result of cause-effect relationships rather than accident or by chance. A measure is statistically valid when we can demonstrate that they did not arise by chance. So in order to establish your validity, statistic validity, you must have appropriate sampling. Sampling will have a simple random sampling, if you still remember, clustered sampling. So please refer back to that, stratified sampling. You have to tell us which sampling method that you are using. Appropriate measurement techniques. How do you measure the result? Like for example, just now we have an experiment, this paper. We have paper where we want to find out whether the addiction, social media addiction, smartphone addiction, online addiction. How do you measure whether someone is addicted? So we have a list of questionnaire here. And this list of questionnaire is actually not produced by us. Like for example, to measure your mental well-being, we use this question. But how do you know that this question is valid to measure whether someone has a good mental well-being or not? Sorry, not only this, but including all this. Yeah, all these are under mental health well-being. And the physical well-being, we have a list of it. But how do you know that all this can represent someone that is with good health or not with good health? How do you know that? The measurement techniques. We are taking this from, actually not from us, it's from other people's work. It's from other people's work. And that's why we will need to actually cite it and let them know that we are using, for example, we tell them that we are using these people work. Okay, all these people work in measuring the social media usage. Additive measurement will be calculated, reported as what and what. Okay, all these are the support for statistical validity. tell people that it's not questionable. My measurement technique is not questionable. Let's take a look at one example. Two groups are tested on memory test with or without caffeine. To ensure statistical validity, you must get enough people to test it. Okay, the sample. And then measure of memory is accurate. How do you measure someone's memory? Do you give them a test? Do you give them a really something like neural detection device or sensor to use to measure the memory? How do you know which measurement is acceptable? You have to read a lot of research paper done by other people. Okay. So we have done the three validity of your research. Number one, internal validity. Number two, external validity. And number three, statistical validity. Okay? Internal validity, which is regarding your DV. Make sure you reduce the confounding factors as much as possible. External validity, most probably if your sampling is okay, adequate, big enough size, then it should be all right. And then statistical validity with good sampling, and then measurement techniques must be correct to avoid this result happen by chance. Now I've come to the last part, or the second big subsection of this chapter, which is about threats, which will cause your internal validity to be violated. What are the threats? Number one, mortality, loss of subjects during study. Means you might keep track of a group of children for 10 years. So within these 10 years, like for example, our ICPSR, right? ICPSR data set, it's from the age of 12 all the way to the age of 2 years old, longitudinal study. So within this period of time, some people might die. Some people might die, mortality. Diffusion, when information leaks from one subject or one group of subject. Subject means the person, the people that involved in your experiment, involved in your research, okay, or a group to another person or another group, and thus modify their behavior. For example, this one, Tuesday we have 160 students come. The subject, these are our subjects, yeah. And after that, before Wednesday, another 160 people come. These 160 people might go and kepo and tell this some of these students and say, oh, they will give you coffee, and then you drink. After that, you must try your very best to run as fast as you can, so on and so forth. So that changed their behavior because of the information leaked by this group of people. That will cause your internal validity to be violated. Next, experimental effects, inadvertent or intentional action of the experimental means those that carry out experiment. Like, for example, if I'm carrying out the experiment for students, so I'm the experimenter. If I am like, I have unstable emotion, if let's say I have unstable emotion, then this will also affect the result. History, changes in the dependent variable that are due to the historical or time-based events, means they might experience something before they join your test, before they join your experiment. For example, Thursday group of students, after Monday, Tuesday, Wednesday, they might have a lot of stress because they need to actually submit the assignment or whatever because of the historical or time-based event, which caused them to change their performance. Next, tracks to the internal validity, instrumentation, the instrument that you are using. For example, the caffeine coffee consumption, coffee. After 2 days, finish the coffee. So you go and buy different brand of coffee. Your instrument got issue, which violate your internal validity as well. Learning, changes in the DV, your subjects that occur due to learning done as a result of participation in the study. For example, let's say we want to test on 100 people and we have 100 sample size. So on Tuesday, this group of people come and I give them coffee consumption. Maybe I give them 1 cup coffee. After that, I ask them to come back on Wednesday and I give them 2 cups of coffee. On Thursday, I give them 3 cups of coffee. But because this same group of people, they learn on Tuesday what to do. On Wednesday, they have learned that before this, I know already what I should be done. I should actually run as fast as I could. And then on Thursday, they've also learned from the previous experiment that, oh, after drinking 3 coffee, I might be able to run even faster, right? So there is a change in your behavior because you learn from the previous. Next track is called maturation. Changes in your DV as well, like your subjects here, they change because of a period of time. They get matured already, so they might change their behavior as well. Placebo effects, this is mentioned also by one of the group. Okay, in I think it's Sukyong's group. Placebo effects, if you still remember the caffeine and placebo effects, placebo groups, you ask a question that do they know that they are drinking coffee? For example, yeah. Placebo effects means that they might thought that they are drinking coffee. The placebo group means the group that are not drinking coffee. For example, if let's say I have 100 students that drink coffee, another 100 students that do not drink coffee, but we give them we give them drinks that taste like coffee, so that they might think that they are drinking coffee. So the highlighted groups are given coffee taste drinks without caffeine. They thought that they are drinking coffee. So they say, oh, I drink coffee, so my heartbeat will increase, and therefore I must run faster. That's called placebo effects. Regression to the mean, the tendency for the subject that had extreme scores in the earlier phases to be less extreme in follow-up scoring. This happens if, let's say, you are using exactly same group of people. As they proceed to the next one, they might not be performing well as well. They get tired already, or psychologically, they think that this is bored, so they don't want to involve anymore. So there is a regression to the mean of the performance. And lastly, sequence effect, the impact of the experience a subject had in one situation on the next situation. This is almost the same as the history here. This is the same as the history because of the previous situation which caused you to change your behavior in the next situation in your experiment. All right, so we have done with the internal validity tracks. Any question? Every day is a blue day. Oh my God, I can't help you. Sorry. Okay, let's move on. Yeah, tracks to external validity. Let's this is week 11 already, so 3 more weeks to go. Okay, Good luck to you. Tracks to external validity. Let's look at external validity. Again, external validity means how good that you can generalize your result to other university, to other time, other places. What are the tracks to externality? Number one, other subjects, other time, other setting. Okay. If you are using only student in this experiment, only student, then you cannot generalize your result by saying that all the athletes, these are the student athletes, all athletes that consume coffee will increase sport performance. You cannot generalize it to other subject because you only involve student. You cannot say adult or primary school student because you only involve undergraduates, which are bachelor degree students. Different age group, okay, different subject. Other time, different time. Would the same experiment conducted at another time, like after 20 years, produce the same result? This is what happened. 20 years back, if you are addicted to the smartphone, definitely your result will decrease. But after 20 years, today, it does not affect. It does not affect. Okay. Other setting. How the phenomena observed in one lab can be related to similar phenomena observed in another lab. For example, we did this in TAR UMT, on TAR UMT student. The 320 scholars are actually from TAR UMT students. We collect data from your seniors. Okay. Then we cannot generalize this and say that this result is applicable to another private university in US. We cannot say that. We cannot make that conclusion. Okay. If you want to carry out this research in other country, in a public university or in a primary school, different setting, right? Different subject, you will have to reconduct the research. You will have to reconduct the research to prove that. Okay. All right, so we have done with the internal validity, external validity, statistical validity, tracks to internal and tracks to external. Let's take a look at this past year question. By referring to the following scenario, identify the type of track to internal validity. Participants in the control group and experimental groups communicate with each other. This communication can influence how both groups score on the outcomes. A, B, C, D. C. Diffusion, correct. Okay, just for your information, this is a past year question. Past year question, yeah. For this year question, the format will be different. Format will become like this one. But for those who haven't joined your lab, I'm going to show you this again. For those who have joined the class, I believe you all are familiar with this, right? It's in this format. Which one following analysis method is correct? Blah, 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 blah. And then we have maybe A, 1 and 2. B, 1, 2, 3, 4. C, so on and so forth. So you choose. Okay, 90% of the questions are actually in this format. All right, so we have done with this chapter 7, which will be included in your exam. Any question before I move on to chapter 8? Chapter 8 will